Hello. Who's out there? How we doing? I just made an announcement in Canvas that I went live, so I'm gonna give people just a minute or two to show up, and then we will get started. I have the 1.2 notes pulled up right here. I don't know how many people are gonna show up this early. However, if you are sitting here and watching me, um, I'm just streaming this early because I want the replay to be available for as long as possible. Are these streams required for them? Essentially, they're not required to watch it live. However, like they're getting the notes from the live stream. I can't follow along because I'm busy, but are you gonna post the replay on YouTube like last time? Yes, it will be posted. You can the link the replay is instantly available on Twitch Cheese. However, the YouTube replay will be available like 30 minutes after, however long it takes to upload, basically, which depending on the length of the stream. Um, if you're here, if you're a viewer right now, you just want to give me an emote in the chat. I don't have a. I've never figured out a good way to monitor the viewers on the stream, to be honest. But if you're watching, you just want to give me an emote in the chat for funsies. Wait, maybe if I do. You're watching the replay right now and can see this message. Appreciate how much Mr. Caesar. Appreciate, thank you. I did the notes ahead of time. Okay. This is hard to. Okay. So let's just go ahead and get started. So this is okay. So right here is the minute marker that I'm going to timestamp in the YouTube replay. So if you just click this, hello, you just click the timestamp. We're doing the 1.2 notes. If you want to follow along, the printable notes are posted in the week 2 module, so you can find the week 2 module notes there. Also, right now, if you're watching this live or the replay, make sure to go in and submit the survey that yes, you watched the replay. Like, go do the live stream assignment 1.2. Right? There's no questions in there. It's literally just, did you watch it? Check the box yes. So I want to know. So you're watching this. You should go check that box. Right? Live stream assignment 1.2. But right now, I'm looking at the 1.2 notes segment addition postulate. So here we go. So, what is the segment addition postulate? Let's just talk about segments in general. Segments have measure, right? We said that lines were infinite and segments are finite. A couple of students even use the word measurable when in the Socrative when I said write your own sentence to describe it. Some of you said the word measurable. That's exactly right. A segment is measurable. So, how do we find the measure of a segment? On the number line, you can count the distance between the two endpoints. Right? It's as easy as that. Just count the distance. So let's count the distance for AB, BC, AC, etc. So let's switch up the colors. AB, 1, 2, 3, 4. The distance is 4. Easy enough. AC, 1, 2, 3, 4, 5, 6, 7. The length is 7. And BC, the length is 1, 2, 3. All right, so I set something up right here. If you're watching this live, you want to pull up that link and answer for AD. You can actually type in a number. You want to answer that question. I don't know if anyone's going to do it or not. I'd love it if you did, so we can have that interactivity. Is anyone here watching? Does anyone want to go to this for me real quick? Minute answer? I'm going to submit one. So you can see my one answer right there. No one's going to do this with me? I don't even know how many people are watching right now. Okay, well, I don't want to waste the replay viewers' time. The answer is simply 1, 2, 3, 4, 5, 6, 7, 8, 9. So the length is 9. So I can finish and reveal that answer. You can see the right answer was 9. So let's add these segments together. Let's talk about the segment addition postulate, okay? So when you're given a segment, good afternoon, how we doing? So when you're given the segment, let me draw one. Endpoints A and B, and there's a point at, say, C right there. What's something that we can say? Well, there's 3 segments on the page there. Do you realize that? There's segment AC, there's segment CD, CB. That looks sort of like a D, doesn't it? CB. Yeah, I clicked to the next question. So if you want to participate, be ready for the next one. It'll come up here in just a little bit. There's 3 segments on the page there. Do you realize that? Segment AC, segment CB, and then the whole thing, segment AB. What's something that we can say about that? We can say, voila, that. AC plus CB equals AB. And I hope that makes a lot of sense. Or in words, the parts add to become the whole. That makes sense, right? The 2 little pieces add up to be the big piece. I hope that makes a whole lot of sense. So if I were to just throw in some random numbers, let me draw another picture. What is that saying? Well, if I had a segment here that's maybe broken up into a piece that's 4 long and a smaller piece that's 3 long, well then, according to the segment addition postulate, the parts add up to be the whole. That means this small piece and this small piece can add together and tell me that the whole thing is 7. Pretty straightforward fact, right? I hope that makes a lot of sense. So that's what we're going to be using. That's kind of our main overarching thing today, the segment addition postulate. So let's use it quite a bit here. Let's draw a picture. It says 3 points are collinear such that B is between A and C. Collinear meaning points that are on the same line. So clearly, these 3 points are all along the same path, and B is between A and C. Write an equation that relates the smaller segments to the longer. Well, it's like I just wrote, right? The two smaller pieces, AB and BC, can add together to become the whole thing. Easy enough. So, if that's true, let's solve for a length here. Suppose that AB is 7 and BC is 3. Well, we know that those two small pieces add up to be the big thing, and it's asking us how long is the big thing? Well, it's as simple as adding those two together. 7 plus 3 equals 10. It's really that easy, right? I have a feeling you're watching it live, you're watching the replay, you're like, okay, I got this down so far. Let's keep it going. Using your answer for AC from the problem above, what would the lengths of AB and BC be if AB were equal to BC? So I want to introduce a new a type of notation here for you. Okay, so it's saying that they're equal. So something that we often do in geometry to say that two things are equal is we use little tick marks like this. Let me switch up the color. We use little tick marks like this in a drawing, in a sketch, to say, hey, those two pieces are the same length. We don't know how long they are yet, but we're saying, hey, those two pieces are the same length. So if AC is still 10, like we just solved for above, and now the problem is saying, well, what if AB and BC were the same? What does that mean each of them have to be? I don't have a question for this in item pool, but if you're alive and breathing in the chat, could you tell me how long each of those are? A, B, and BC. If the whole thing is 10, and those two small pieces have to be the same length, that same length is how long? Darius, you still there? How long are each of them? I know you got me. If the whole thing's 10, each of them are. Oh, not a lot of activity in the chat. They're each 5. 5 and 5 adds to 10. Right? If they're each the same length, 5 plus 5 equals 10. Perfect. Let's amp it up another notch, okay? So let's do another drawing. Here's a long segment that has, it says N is between L and P. Thank you, Talon and GoTo, for answering. I appreciate you. Talon, do you get why it's 5 though? You said 2 maybe because it's like 2 times 5 or something like that. That might have been what was going through your head. So N is between L and P. So there's N. It doesn't say in the middle, it just says somewhere in between. So L and P are on the ends, there's N. And M, the letter M, the point M, sorry, is between L and N. So there's M between L and N. And then O is between N and P. So it's always a good idea to draw a sketch. Always sketch it out, okay? Always draw a sketch because geometry is very visual. So let's write down what we have, what we know here on each of these. So we know that LP, that entire distance, is 18. And we know that LM is 12. Now, I know it doesn't really look like, I didn't really draw this to scale very well, but, you know, sometimes that's going to happen. Um, what is the measure of MP at this point? I got a few of you here. Go to that link if you can, if possible, on a second device or on a new tab. I'd love some participation. If the whole thing is 18 and LM is 12, how long is MP? That's kind of the first place I want to start at. So how long is M to P? So I just submitted an answer. You can see the little bubble pop up there. If I can maybe get, you know, the two of you to answer that, just message in the chat. That'd be great if possible. Just to get some participation. Again, I don't want to slow down the replay viewing. You can always, if you're watching the replay, feel free to skip until the bubble disappears, right? Because you're just looking to get the answer at this point. You should see the link right above me. It says answer at itempool.com/skis/live. Again, if you're watching the replay, this could be you participating in this live. Eventually, once there's enough people and we all get used to this, I'm just trying to make this as interactive as possible. Once we get used to this, and if you tune in, I don't know if you're still watching the replay or if you've skipped forward at this point, we can start to. So the way these bubbles are working here, that means we have two different answers at this point, right? Or because if they were the same answer, it would say two of the same thing. So at this point, we have two different answers. All right. To not drag this on too far, I appreciate you, probably Talon, who just submitted that. Let's go ahead and click Finish and Reveal on this. So my one submission was the right answer. 16 wasn't quite right. So so what's the deal here? We've got this piece. So at this point, the replay is probably with us. Let me go ahead and switch to this one and get rid of the link there. So if this piece, again, this piece is 12 right here. So how long does this need to be? Well, together it adds up to 18, right? So essentially we're saying 12 plus what equals 18. That's what we're saying. So that means so subtract the 12 from each side, 6. So that means this right here is, oops, I just accidentally erased too much. That means this is 6. 12. The LM piece is 12. And then 6 right next to it. That whole thing is 6. So it says MN and NO and OP are all the same. Check, 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 right? Remember I said the tick marks, that's a common notation that we're going to see together quite a bit in geometry. That means each of them are the same. So if MP is 6, and then that piece is broken up into 3 smaller pieces, well, each of those 3 smaller pieces are, maybe you can guess with me, 2, 2, and 2. 2 plus 2 is 4, plus another 2 is 6. So each of those small pieces are 2, 2, 2, 2. It doesn't ask for OP, so there's not a third 2 in the blanks here. It asks for N to P, which is 2 of them, so that's 4. And then L to O. L to O, well, that's a combination of 12 and 2 and another 2. You see that from L to O? So 12 plus 2 is 14, plus another 2 is 16. So we're just repeatedly using the segment addition postulate, which is this idea that the smaller pieces add up to be the big thing. So we're breaking up this big thing that was 18, let's just say it's inches, 18 inches long, and we've broken it up into these chunks. 12 and 6, 12 and 6 make 18, or break it up even more, 12 and then 2, 2, and 2. Again, 12 plus 2 plus 2 plus 2 in the end still equals 18. Okay, what is the next question that I had set up for us? Oh, I had another. We'll skip that one. Sorry. I had two questions for that one set up, but I forgot. So let's make another drawing. Time is it? 2:25? Oh, easy. So suppose J is between H and K. Here's H. Actually, let me just give myself a little bit more room. I don't want to draw it so far down. Here's H, and here's K, and here's J in between the two of them. Now we've got this variable, right? A little bit of algebra coming in. I know we're in geometry, but we're going to do a little bit of algebra here too. So this distance, let me switch up color so it doesn't blend too much. The distance from H to J is 5x minus 3. And the distance from J to K is 79. Got a little prettier 9. And the whole thing is 3x plus 144. So I know that there's a little bit more going on with the x here, but I want us to think about this super basic, okay? Whether you're watching me live or whether you're watching the replay, let's think about this super basic. Ignore the x's, ignore the numbers. What statement is true about this segment? We can say hj plus jk equals hk. I think that's something we can all agree upon, right? The two small chunks, hj and jk, the two of those combined together, all right, let me go. Two of those things combined together make the whole thing, all right? That's pretty easy logic there. So, how long is hj? Well, we don't have a number, but we know that hj is 5x minus 3. How long is jk? We were actually given a number. It's 79. And how long is hk? We weren't exactly given a number, but we were given 3x plus 144. Let's work with that. There's our equation. You solved those probably in your sleep in the middle of Algebra 1 last year, right before the year ended. I know that might seem like quite a while ago, but you were solving these in your sleep. I know it, okay? So let's combine like terms and solve. I have, if you're watching right now and you want to beat me to the punch, if you can solve for x, solve for it right now. Beat me to the punch. There's the link. You can submit your answer. I don't know how many people are watching right now, but if you want to beat me to the punch, there's your link to submit the answer. First thing I'm going to do is combine like terms. So 5x minus 3 and 79. These guys can combine. So 79 minus 3 is 76. And then nothing to combine over here. I'm sorry, I'm running out of room. So let's circle back up here. Let me rewrite it. Now I have some more room to work downwards. Again, the link is right there for submission if you want. So then we got to get x on the same side, right? So let's subtract 3x. Combining terms, move that over. And then while I'm at it, let's go ahead and move the 76 over to the right side. So I'm canceling out the 3x and combining it with the 5x. And I end up with 2x. A little thirsty. And then I'm going to subtract the 76. 144 minus 76. You might have to break out a calculator for that, but the answer is 68. And then how do I cancel out that 2? Divide by 2. X equals... Doesn't look like anybody submitted an answer, but that's okay. Maybe we'll slowly get the hang of it. X equals 34. Oh, I'll submit that answer. 34 is my answer. I'm going to finish and reveal. Oh, one of you just submitted 34 with me. Oh, we got a third one. Thank you. You're awesome. And see, there's the reveal 34. The more people we get in here, the cooler that can be. We'll start to see some wrong answers, a lot of right answers, right? I think that'll be cool when we start to get the hang of it. So the answer is 34. So what can we do with that? Well, how do we solve for hj now? Well, we know 34. So it's as easy as plugging it in, right? If hj is 5x minus 3 and we now know x, well, 5 times 34 minus 3. 5 times 34, what is that? I do not know that off the top of my head. 5 times 34 is 170 minus 3, 167 is the answer for HJ. Do the same thing for HK. If HK is 3x plus 144, plug in 34 for x and solve. 3 times 34 is 102 plus 144 is, I'm just got a calculator up on my end. I know you can't see it, but is, I just forgot. What was the answer? 246. Check this out. How can we check that we have the right answer? Check your answer. Well, if we're saying HJ is 167 and we already know JK is 79, what is 167 plus 79? 167 plus 79. If you can do that on a calculator on your end, but you'll just have to believe me. I know it'd be a lot more work for me to just pull up this screen than it's worth. Plug it into a calculator. The answer is 246. Checks out, right? Because HK we said is 246. The math works out, right? If that math didn't work out, then we've got a number wrong somewhere. All right, we're almost done. This is the last example. So let's draw a picture one more time. That's always a good idea. R is between X and Y. R is between X and Y. And it's asking us to write another equation. So again, we can say that the two small pieces add up to be the big one. This is really important that this makes sense. If that's still if you're looking at this now and if you're watching this live with me or if you're watching the replay and that statement isn't making sense, scrub backwards 20 minutes or 15 minutes or so and look at this again, right? And hear me talk about this again. All right? What we're saying here, I'll say it short and sweet to the point. The two smaller pieces, XR and RY, combine to be the whole. So let's use that equation to solve. It says if XY is 19, which is this piece, right? Be careful. It's not telling me XR is 19, it's telling me the whole thing is 19. And then RY is 8. How long is XR? There's our equation. You see how I just plugged these numbers into this, right? That's what I just did. I hope you realized that. All right, I took these two numbers and plugged them into this. So XY is 19 and RY is 8, but I still don't know XR. That's what I'm trying to solve for. So let's go ahead and do that. Subtract the 8, XR equals 11. And 11 plus 8 equals 19. Perfect. Again, we've got some variables coming our way. Hey, we just had a notification there. What was that? I missed the notification. Thank you for the follow, though, probably. Um, so let's use the same equation. All right, let me write it down again. XR plus RY equals XY. So XR is 2x minus 3. It's right there. I actually have a an item pool question for this. Let me go ahead and click next. If you want to solve for XR, all right, there's the link. I'm going to solve for XR. Right now I'm writing the equation, but if anyone's watching and wants to beat me to the punch, you can solve for XR and use that link. But I'm going to go ahead and write out the equation. So XR plus RY, it says it right there, is 3x equals XY, which they told us is straight up 27. Easy. Let's solve that equation. So combining like terms, 2x and 3x is 5x. So still solving for x here, so let's add the 3 over to the other side. And then divide by 5, x equals 6. The question that I'm asking on item pool, though, I'm not asking you to solve for x, I'm asking you to solve for xr. If that is x, what should we do with that to solve for xr? We should take it and plug it in. So let's do that. 2 times 6 is 12. 12 minus 3 is 9. And let's go ahead and solve for ry as well. If ry is 3x, just plug it in. 3 times 6 is 18. And you betcha, right? Those two small segments. Again, this is the picture. I didn't draw it again, but we've got x, y, and r. What are we saying? We're saying xr is 9 and ry is 18. And yeah, 9 plus 18 together, they make the whole thing, which they told us is 27. The math checks out. One of you submitted the answer there. I'll go ahead and finish and reveal. Boom. Good job. Thank you for submitting that. So, wrap up. In your own words, state what the segment addition postulate is. It's kind of the thing that I've been saying over and over now. I mean, this is in your own words for you to make sense, but my own words is what I honestly already wrote up here. The parts add up to become the whole. But let me phrase it another way since we've already written that down. How about um segment addition postulate says the smaller segments can be added to find the larger segment. I honestly liked my initial wording. The parts add to become the whole, but if I had to say it another way, that's what I'd say. But honestly, I like my other way better. The parts add to become the whole. That I mean, to me, that makes the most sense. And we did it. You've reached the end of the replay. Person who's watching the replay, make sure to go do the survey. People who are watching the live stream right now with me, hey, thanks for tuning in. You just watched the live stream. You can go submit that survey right now, too. Yes, I watched the live stream. If you want to stick around and ask some more questions here while I start to get set up for Algebra 2, please do that right now. I can keep an eye on the chat. Um, yeah, let me, if you want to message in the chat, It says collinear there. What does that mean? Collinear. Back up way up here. 3 points are collinear, such that B is between A and C. To be collinear means that the points are on the same line or segment. So these 3 points are on this one segment, so they're together on the same line. These 3 points aren't collinear, right? Because I can't draw a straight line between the 3 of them, right? I have to draw a zigzag. So to be collinear means they're all on the same line. Thank you, Talon, for chiming in on that too. I appreciate you. I'm wanting to pull up Desmos for Algebra 2. I'm going to go ahead and post an announcement in Algebra 2 that I am about to start, just so I can draw in some viewers potentially. Live on Twitch. Starting the Algebra 2. Here's the link. Check back later for the replay. If remember, all the links are in live stream assignment 1.2. And then link to set it. Raspy. Clutch. There we go. So not the same as collinearity in statistics. Linearity in statistics. Correlation between predictor variables. All right. Yeah, I'm pulling up the graphing calculator for Algebra 2 because we're going to graph some quadratics. So I'm starting to shift into Algebra 2 now. I'm going to back out of these notes and migrate on over to Algebra 2. If you're here for Algebra 2, welcome. We're almost getting started. You too, Talon. I'll see you in class tomorrow/Tuesday. I'm going to go ahead and pull up my notes. Sorry, Algebra 2 people, if you're waiting around for me. Almost there. I'm sorry. Okay. So, what's up? How are you? My geometry, and now you're here for Algebra 2? Or you're just here randomly and you're not in any of my classes right now? Why does it say I'm not logged into Twitch right now? Do I need to be in your class to get help? No. Don't have to be. I'm going to be focusing on my class right now, but I could easily help you on anything you'd like. I'm going to start their notes. Holy. Given is the equation x squared plus 10x plus 25 equals 0. Determine the values. What is the a before the 6 there? Values a6. To me, that looks like a typo. Determine the values. Are you trying to determine when the function equals? You're just trying to solve for x, right? So like, when does the function equal 0? I'll show you super quick. X squared plus 10x plus 25 equals 0. Factors. So what multiplies to 25 and adds to 10? X plus 5 times x plus 5. Set your factors equal to 0. X equals negative 5. All right, I'm going to start my notes. You can let me know here in a sec if that made sense and if that answered your question. All right, hello, Algebra 2. Right here is the start of the replay when I post it on YouTube. So, welcome. If you're watching live, you're watching the replay, don't forget the 1.2 printable notes are located in our module for you to find and to follow along and to fill out. Also, don't forget to submit the live stream assignment 1.2. The people who are watching live right now, feel free to go fill that out right now since you are watching or afterwards. And people who are watching the replay, when you're done watching this replay, go ahead and fill out live stream assignment 1.2. Just go ahead and check that box that, yes, you have watched. I really appreciate you filling that out so I know who did what. So, let's jump right into it. There's not too much to write down here. There's just a whole bunch of writing. Let's read through and look at the particulars, okay? Point out the important things. A quadratic function is a function that can be written in the form blah. The most basic quadratic function is f of x equals x squared. This function is often called the parent quadratic function. Once you understand the graph of the parent function, you can understand the graphs of other quadratic functions. To graph f of x equals x squared, make a table of values, plot the ordered pairs, and draw the graph. Thanks for following, Sword Gear. So, they've already done that for us. Let's take a look at this. Again, remember, let me draw my own and show you how those are coming about. We're plugging in x, and we're plugging it into the function f of x equals x squared. That's what we call a parabola or a quadratic function. That's what we're looking at right now. So let's plug in some numbers. Let's plug in 0. Well, 0 squared is 0. So when I plug in 0, I get 0, hence why we have the coordinate 0, 0. When I plug in 1, 1 squared is 1, hence why we have the coordinate 1, 1. When I plug in 2, 2 squared is 4, hence why we have the coordinate 2, 4. When I plug in 3, 3 squared is 9, hence why we have the coordinate 3, 9. That's how a function works. So this thing is going to keep growing. And why is it growing so quickly? Because we're squaring, and the numbers get that much bigger that quickly. 5 squared, 25. 6 squared, 36. 10, all of a sudden we're up to 100. This thing's growing very rapidly, and we call this a parabola or a quadratic function. And when you do it on the other side, when you square a negative times a negative gives you a positive, which is why this is growing the exact same way on the other side, because the negative is canceling out. And we're getting those same coordinates, negative 1, 1, negative 2, 4, and lastly, negative 3, running out of room here, 9. That's the parent function, and parent meaning like the most basic version of the graph. Okay? Parent function meaning the most basic version. The most basic version. Okay? Let's look at some more nitty gritty here. The graph of a quadratic function is called a parabola. I already used that word, which can either open up, as the graph of the parent function shows, or down. The highest or lowest point on a parabola is called the vertex. So when you're looking at this particular parabola, the lowest point, let me do red, is right here. That thing is the vertex. It's the tippy tippy top or the tippy tippy bottom. That doesn't make any sense. The super duper bottom, okay? That thing, that point is called the vertex. And that's like right smack dab in the middle. I hope you can agree with that. That's right smack dab in the middle. And we could essentially split this thing in half with a line, right? That line has a name. That's called the axis of symmetry. You've probably heard the word symmetry before. For something to be symmetrical means it's the same on either side. This parabola is the same on either side. It's perfectly symmetrical. Oftentimes people think that faces that are the same on either side are the prettiest, right? Because they're symmetrical, everything's even, right? And that's what that said right there. The axis of symmetry divides the parabola into two congruent halves and passes through the vertex. For the graph f of x equals x squared, the vertex is 0. I already pointed that out. So, like I said, that is the parent function. That's the most basic version. But pretty easily, we can start to shift this parabola around. Shifting is a big buzzword. Shift up, down, left, right. Make it fatter, make it skinnier, flip it upside down. We can do all kinds of things to it. And those things are called transformations. Okay? All of those movements are called transformations. And once you get the hang of it, it's so easy to plot a parabola. Like, it really is. So, oftentimes, you will see a parabola written in what's called vertex form. Let me write that word down first. You will often see a parabola written in vertex form, and that looks like this. Actually, let me squeeze in f of x in here. F of x equals a times x minus h squared plus k. I know that might look like a lot right now, but trust me, you're going to love it, okay? It's going to make life so much easier. You're going to wish everything was written in vertex form, and you're going to be irritated when it's not written in vertex form, okay? So what do each of these things tell us? And when I say each of these things, I'm talking about A, H, and K. What do each of these things tell us? Well, let's start with H because H controls the horizontal shift. Horizontal shift means the left slash right movement. Okay? To horizontally shift means left slash right, and that is controlled by H. Okay? That's controlled by H. Let's just write these down, and then we'll really start to see this like in motion. Okay, but let's just write these down real quick. Even if you're not fully understanding, let's just write them down so that way we have it. And trust me, it'll make sense here when I show you a couple of images. So vertical shift, you guessed it, is the up slash down movement. And that's controlled by K. Okay. Shrink and stretch are both controlled by A. So a shrink is when it gets fatter or shorter. Kind of depends on how you look at it, okay? Or wider. Those are all adjectives that will make sense visually to you, trust me. And that's when A is between 0 and 1. Okay? The absolute value is between 0 and 1. And a stretch is when it gets skinnier slash taller. And that's when A is bigger than 1. Lastly, a reflection is when it gets flipped upside down. And that's when A is negative. Okay, so let me show you some stuff on Desmos. So, you can't see the equation that I'm about to type because of my webcam. I'm going to be behind the chat. I know that's stupid, but I can't fix that right now, so it is. All right, so I'm behind the chat. Hi. Okay, so let's look at the parent function. There she is. Okay, I won't give it a gender. There it is. H and K control the left and right movement. Okay, H and K control the left and H controls the left right and K controls the up down. H is the horizontal shift, K is the vertical shift. So let's take a look at what happens. All right, let's start to move it up down, which is K. Okay, let me make it look exactly the same. So X, let's make H 0. All right. So there's that, right? There's the parent function. We haven't moved it left or right, okay? Let's start to move this thing. Let's move it. If we want to move it up 2, let's make K 2. Look at that. It's as easy as that. When K is now 2, we moved it up 1, 2. Okay? 1, 2. I can change this to 3. Now I moved it up 1, 2, 3. Remember, red is the original parent function, and the second I add 3, I've now moved it up 1, 2, 3. Or I could move it down. I can move it down 1, 2. It's as simple as changing this one number. If you don't put anything there, well, then it hasn't moved at all. But the second you maybe subtract 5, it's moved down 1, 2, 3, 4, 5. That's all there is to it. Everything else is the same. You realize that? Everything else is the same. 1, 1, 2, 4. Remember those numbers from the parent function. 2 squared is 4. 3 squared is 9. Everything's the same. 1, 1, 2, 1, 2, 3, 4. The growth is exactly the same. It's just been simply shifted down 5. Okay, let's leave this at 0. Let's start to put in a number here. Minus 1. Where do you think it's going to go? I bet if you're watching live with me or watching the replay, I bet you think it's going to move. Well, I don't know. Where do you think it's going to move? Minus 1 moved it to the right. 1 unit. 1. Minus 3. 1, 2, 3. Minus 5. 1, 2, 3, 4, 5. So by subtracting 5, we moved it right 5. And by adding 5, you move it 1, 2, 3, 4 left 5. Again, it's as simple as changing that number 1, 2, 3, and that's the movement that's going to occur. Let's combine 2 at the same time. What is this saying? Left 3, up 2. 1, 2, 3, up 2. I want to go right 7 and down 3. 1, 2, 3, 4, 5, 6, 7, and down 1, 2, 3. Vertex form, if you're not already in love with it, right, you're going to fall in love with it real quick because it's that easy. You just read off those numbers. Okay, let's think about the vertical, the stretch, sorry. So what did I say on this previous page? Again, this is just me tinkering around, and I encourage you to tinker around on your own time on Desmos to see what exact I'm not doing. I'm just kind of we're just sort of experiencing this together, okay? So I said when A is bigger than 1, it stretches, which is skinnier slash taller, and when it's between 0 and 1, it gets fatter, shorter, or wider. Okay? So let's check that out. Let's go back to Desmos here. So when it's bigger than 1, let's say 2, boom, you see how that's skinnier? Red is the parent function, green is our new function. We just made it skinnier. Or another way to think of it as because like I said, because we're stretching, imagine taking your hair tie or a rubber band or something like that, right? If you mush it, it starts to flatten out and get wider. If you stretch it, it starts to get super skinny and long, right? So I can stretch this out a lot. What if I make it 7, right? Look at that. So it's way skinnier, right? It's getting stretched out. It's way taller. Why am I using that word taller? Because instead of it being 1 1, it's now 1 4. That's much taller, right? It's growing a lot quicker. Okay. Or the other way around. I said if it's between 0 and 1, that it's going to get shrunk down. It's going to be fatter, shorter, or wider. So, what does that look like? So, if I make this zero point 0.5, you see how that's wider? It's opening up. The mouth, so to speak, is bigger. Again, taking that hair tie analogy, you can stretch it out and make it super skinny. Or if you kind of mush it back together, you flatten it out and kind of make it like this long oval looking thing. You're widening it out. Again, if I make this, I mean, let's not just use decimals, let's use a fraction. So how about 1/3? Why put that parenthesis there? That's weird. 1/3. That just got even wider. 1/4, even wider. 1/5, even wider. I can have 3/5, not as wide. Again, I can as long as it's less than 1, it's going to be wider. And if it's literally 1, it changes nothing. Right? Smaller than 1, a little bit wider. Bigger than 1, a little bit skinnier. Less than 1, a bit wider. A bit skinnier. All right? That's all it takes. Literally, the rest of this lesson is just graphing. So I feel like me spending all this time on Desmos is worth it. Because the more you look at this and you're like, wow, this is making sense, the better and easier everything's going to be, right? I want you to let this sink in and really absorb what's happening. The one thing I haven't shown you is if we make it negative. So let's see what happens when we make it negative. So -1, right? It's the exact same function, but now it's flipped. Yeah? -1.5. So I made it skinnier and flipped it. Right? Because 1.5 is bigger than 1, so it's getting skinnier. I can make it super skinny, right? Let's go back to 7. Super skinny and flipped. So let's analyze this all one more time. Let me copy this and make a third function. So I could stretch it. -3, is that going to move it left or right? It's going to move it right 3. And I can move it up 1. Look at that. The vertex moved right 3, up 1, and then it was stretched. Let me hide these. Let's do this again. Let's flip it. Move it maybe to the left and down. So -2 means down 2. +6 means left 1, 2, 3, 4, 5, 6. Negative means flipped, and 1.5 means a little bit skinnier than usual. All of that's coming together. Now I know the calculator is just graphing it for us, but I mean, I just want you to be able to make that quick sketch. That's really all I want. Okay, I'm not gonna worry too much about the nitty gritty, especially in this online landscape. It's kind of hard for us to worry about the nitty gritty, and the fact that Desmos can just do it for us, I don't think there is a need to worry about the nitty gritty. Okay, so let's flip back to the notes and let's try as much of these as possible. Sorry, just getting a little set up on my end. So, graph the quadratic function. So the main thing that I want you to see and look at is if you didn't realize, right? This is called vertex form because the vertex is HK. Again, the left and right, up and down movement. So if it helps to write this like this, then so be it. Okay? There is no h in this situation. This is our k, and that's telling us to move up 1. Simple as that. So this parent function has already been pre-plotted for us. So all we're doing is we're moving this vertex up 1. Okay? That's it. And then everything's being moved up 1, 1. Here's another clean point. Right? Okay, let me stress something. What are the nice points? Again, 0, 0, 1, 1, 2, 4, and 3, 9. These are the nice, and when I say clean points, I mean whole numbers. So let's move them all up 1. Boom. That's it, right? What is this telling us to do? There is no K, right? So there's no vertical movement. That's just 0, right? And minus a number means move it right. Add said number, move it left. So minus 3 means right 3. So again, what are the nice clean points? Here, 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 and here. Let's move them all right 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. That's it. That's simple. It really is. That's simple. What is this telling us? Is that -3 an H or a K? You're watching the replay, you're watching it live. Answer that to yourself. Is that an H or a K? That's K. So that's telling us to go down 3. Where are the clean points? Here, 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 and here. Move it down 3. 1, 2, 3, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Boom. There is our function. I don't want you to overthink this. Now you might be thinking, well, how do I graph it when the parent function's not there? Don't worry about that right now. Trust me. Just don't. That's what your graphing calculator is for. Right? I just want you to understand the movement, okay? I just want us to be on ground floor here. Don't worry about that too much. Worry about just, do you understand when looking at this what the movement is going to be? That's what we need to know right away at the start. Mm-mm-mm. Oh shoot. I forgot I was going to do an item pool question. And I'll save that. I'll skip it. So let's answer these questions here because we're doing a little bit more of the nitty gritty. Remember, the vertex is that bottom or top point depending on what it looks like, right? It's either the tippy top or the tippy bottom, as I said earlier. So what is this vertex? That point is 0, -3. So is that the lowest point or the highest point? Obviously, it's the lowest point, so we call it the min. And how low is it going? -3. Let's answer some domain and range questions. This is a callback to last lesson. Domain is the x values, range is the y values. So without overcomplicating this, just look at this graph, and as it goes up, 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 and up, 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 where is it going? It's going to the left and to the right, gradually. It's going to go forever to the left and forever to the right. I can't stress that enough. It's going forever in each direction, so we call that all reals. Easy peasy. The range is the y values. Well, what is the lowest y value? We already answered that question right here, right? That is the smallest y value, right? Because it's the min. So the range is -3 to infinity, right? That's where it's starting at -3, and then it just goes up like a psychopath. It just goes up, 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 up to infinity. So -3 to infinity. I made an item pool question for the next one. I said, what direction is the graph g of x going to move an example to b? That was what I asked. If you want to submit a result, so what direction is it going to move? Left one, down one, right one, or up one? I don't have a lot of viewers live right now, which is okay. But if you're watching the replay, this is the experience that you could get if you showed up live, okay? You could submit to this link and answer these questions live, and we can start to see these results. Um, that's interesting. All right. So which way is it going to move? Is that H or is that K? That's H. It's telling us that we're going to move right one. Nobody submitted the answer. That's okay. But next time we can submit the answer. Right one. So move them all right one. Boom, boom, boom. But that's enough, right? We get the point. I'm not stressing. I'm not stressing. Move it right one. What's important is, okay, if the vertex is at 0, 0, right one means now it's at 1, 0. Those are some of the details that we want to care about. Is this a max or min? It's a min, right? At 0 still. It didn't move up or down. Our domain, spoiler alert, every single parabola, the domain is all reals, right? It's going to go forever left and right. It's never going to. Why wouldn't it be all reals, right? It's just going to go up, 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 and left, 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 and right, right, right. It's always going to be all reals. And the range, again, it's always going to match this value, right? That's the lowest possible point. So it's starting at 0. See, I'm using that bracket to say included. And then it's going to go up, 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 up to infinity. Okay. I'm just going to do one more of these because I think we're getting the point probably as we're watching the replay or watching live now. One more though. What is this telling us to do? Right, 2, up, 4. Boom, right? If you can see that, if it's that quick, it needs to be that quick. It's gonna be that quick. If you put in the work, you put in the time, it's gonna be that quick. So, right 2, up 4. Boom. How did I just get to that point so quickly? I'm looking at the vertex. It's at 0, 0. So, right 2, up 4. Holy, how'd that happen? Right 2, up 4. Boom. There's the vertex. And then it just goes up from there. Again, I ain't stressing. Like, we get the point. Okay? I think we all know how to move these points right 2, up 4 at this point. So now the vertex is at 2, 4. You see how this matches every time, right? That's the point. Vertex form. And it's asking for the vertex. H and K, I mean, literally, you just, right? 2, up, 4. Boom, that's the vertex. This has a min. The lowest point is at 4 now. I already said it. Domain is all reals every time. So it's starting at 4 and going off to infinity. All right, let's spice it up a little bit with a stretch and shrink action. All right, I'm going to skip. We don't need to do all of these. I think we're probably going to go numb from graphing so many if I were to do all of these. But let's just quickly state whether it's a stretch or shrink, because that's something we need to be on top of. Remember, if the absolute value is a is bigger than 1, it's a stretch. Why? Because multiplying by big numbers stretches things. It makes them bigger. Times 2, times 3, times 4. You're enlarging it. You're stretching it out by multiplying by such a large number. 5, 6, 7, 8, all bigger than 1. If you shrink something, you multiply it by something less than 1. Right? Between 0 and 1, something less than 1 is going to make it smaller. Take half of it, take a third of it, take a fourth of it. Shrink, 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 shrink. So what do we got? This is a stretch. This is a shrink. What do we got? This is a stretch. This is a shrink. That easy. What do we got here? A flip and a shrink. Just a shrink. Okay. So let's do one basic one and one with a little bit of action, and then we'll call it. Okay? So which basic one should we do? Let's do this basic one. Negative 3x. Or we should probably do one basic stretch and one basic shrink. Let's do that. So how does a shrink work? Okay? Because it's not as simple as write 1 down 3, right? Because that's shifting. How do we shrink everything? We're not subtracting 3 to everything. That's not what's happening here, right? Because this is a stretch. Anyway, things need to get bigger. I want you to think back to the table of values for this parent function. Okay? I'm not trying to take too much of your time here, but I am trying to help you understand it. So look at this table of values. So one, because again, right, you're plugging in x, you're getting x squared. I don't know if I need to repeat myself on that one more time. 1 squared is 1, 2 squared is 4, 3 squared is 9. So that's what these 3 points are, and 0 squared is 0. Okay. What happens when you stretch it now? You're multiplying everything by 3. So yeah, 1 squared is 1, but then it gets stretched by a factor of 3, so now it becomes 3. Yeah, 2 squared is 4, but you're multiplying it by 3, so all of a sudden that's become 12. Yeah, 3 squared is 9, but you're stretching that out. You're making it so big. Now it's 27. 9 times 3 is 27. So to stretch it by a factor of 3, I mean, it just makes it super tall, super quick. I mean, none of those points are really on our graph except for the first one. So let's go ahead and plot that. So 0, 0 stays put, right? That one stays put because 3 times 0 is 0. But when we stretch it by 3, now this is up to 3. And this is all the way up to 12, right? We're that skinny now. And the exact same thing on the other side. That's how we've stretched it. Oh, shoot. Something I just realized, though. It's negative 3, derp. So it got flipped. So this is 3x squared. Let me just go ahead and graph both. But my bad. It's negative 3x squared. Let me choose a better color than that. Negative 3x squared. So it's the same thing except flipped. We'll just, again, it's just super skinny. It's kind of hard to graph. It's going off the graph super quick. Okay. So let's focus on the yellow one here because that's the one that actually mattered. Let's answer these questions. The vertex is still at 0 because it got flipped. This is our first occasion of having a max, right? That's the tippy top now, and that maximum value is at 0. Domain is all reals, forever left and right. But our range, what's the smallest it's going to get, right? These were all, the smallest was the number right here, right? And it just went up from there. This is actually the tallest it can get. So that's where it's going to end. And the smallest it can get, super negative, right? Negative infinity. All right. So again, imagine with me this table of values, and now we're shrinking everything by a quarter. You plug in 1 squared is 1, but now you divide it by 4? Not an equal sign. Now we're multiplying it by 1/4, which is the same thing as dividing by 4. So now you got this teeny number, 1/4. 2 squared is 4, divided by 4 is now 1 when I multiply it by a fourth. Fractions freak people out. If you got to plug it into a calculator, then I guess so be it, right? How do I, where's the scientific calculator on Desmos? Let me just switch for this for you real quick. So 2 squared is 4, but when I multiply 4 by a fourth, I get, oops, I get 1, right? 3 squared is 9, and 9 times a fourth is 2.25. Again, I don't want you to stress about these messy numbers. That's not what I'm trying to get at. I'm trying to help you realize how everything is being shrunk down, right? It was 9, and when you multiply it by a fourth, it makes it a lot smaller, only 2.25. 4 squared is 16. 16 times a fourth is 4. So when we shrink this down, we got 0, 0, and then 1 comma a fourth, right? So that's like right there, I guess. And then 2 comma 1. I guess that's like right there. And then 3 comma 2.25. I guess that's like there. And then 4 comma 4. I guess that's like right there. The point is look how much wider that is. I don't want you to stress about the particular numbers. That's not what I'm here to do. Okay? But I just want to help you realize how all those numbers, they were big, 1, 4, 9, 16, and then they all got divided by 4 and got a lot smaller, hence the word shrink. At 0, 0. It's got a min, it's at 0, it's all reals, the range is 0 to infinity. All right. I'm sorry how long this is going on. Let me do one last one. Let's do this one, and we'll call it. Okay? So, well, let me just. What do we know? Let's just casually look at this. What do we know here? It has been flipped. It has been moved. Flipped because it's negative. -5. What does that mean? Right 5 or left 5? It means right 5. And -2. What does that mean? Up, down, or down 2? It means down 2. Flip, stretch, shrink, horizontal shift, vertical shift. So the shifting was easy. 10 minutes ago when we were doing shifting, You're probably like, oh, this is easy. And it still is. So right 5 and down 2. Boom. There's the vertex. Again, vertex form tells you the vertex. Boom. And then it's been flipped. So it still has the same growth 1, 1, 2, 4, 3, 9. But now it's been flipped downwards. So let's go down with that same trajectory, right? It didn't get skinnier, it didn't get fatter. There was no stretch or shrink, it just simply got flipped. That's all there is to it. So your max or min, it has a max now, right? That's the tippy top. Your what is that maximum value? -2. What's the domain? It's always all reals. Don't even worry about it. And what is our range? What's the lowest it can get? -infinity. What's the tallest it can get? -2. And there it is, folks. You've reached the end of the replay. If you're watching, go fill out the survey. The did you watch it? Yes, you did. Go do the 1.2 live stream assignment. Thank you for watching. The homework is probably posted at this point. If you want to start it, you could homework, the classwork, right? You've watched the stream. I appreciate you. We're gonna come to class and we're gonna do the classwork. You are on it. So good job. Thank you for watching. The stream is ending now. All right. Appreciate you.